Albedo is the percentage of solar energy reflected by Earth. This contrasts with libido, which is sexual energy reflected in other ways. The albedo of various materials range from about 85% for pure, fresh snow to 5% for asphalt parking lots or deep, still waters. The global mean is about 29%. Satellite measurements provide a worldwide perspective on albedo. Clearly, deserts and snow-covered regions have a high albedo, whereas forests and agricultural fields have a low albedo. The overall trend seems to be that global albedo is decreasing, most likely from diminishing snow and ice cover. This change in albedo will increase the amount of solar energy absorbed by the planet. Before we examine atmospheric composition and the so-called greenhouse effect, let's try to become comfortable with the concept of energy. A classical definition is that energy is the ability to do work, where work is a force applied over a distance, and a force is that which has the ability to change the motion of a particle. Is that clear? Perhaps a more useful definition of energy is the capacity to change environmental conditions. For example, the capacity to change the temperature of a substance. This capacity, this energy, is never created nor destroyed. It is just transformed from one form into another. This is the conservation of energy law, or the first law of thermodynamics. The dominant form of energy impinging on Earth as it travels through the void of space is electromagnetic radiation. The conservation law dictates that the amount of electromagnetic radiation entering Earth's sphere of influence must equal the amount leaving this sphere. Electromagnetic radiation has a characteristic wavelength, lambda meters, or frequency, nu in cycles per second, or hertz. Either wavelength or frequency will suffice to define electromagnetic radiation, because the product of the wavelength and frequency must equal the speed of light. C equals lambda times nu. If given a wavelength, one can calculate its frequency. Nu equals 299,792,458 meters per second divided by the wavelength. Electromagnetic radiation extends from radio waves with long wavelengths, slow frequencies, on the order of a kilometer, to gamma rays with short wavelengths, high frequencies, on the order of picometers, 1/1,000,000 of a millionth of a meter. Visible light falls in a narrow band between the middle of the spectrum between 0.4 and 0.7 micrometers. The energy of electromagnetic particle wave is proportional to its frequency, according to the equation E equals h times nu, where E equals energy in joules, h is Planck's constant, which is 6.626 times 10 to the minus 34th joules times seconds. Nu is cycles per second, or hertz. Therefore, a radio particle wave contains far less energy than a particle wave of visible light, a photon, which in turn contains less energy than a gamma ray.